Good morning, children. Today we'll start with this portion in page 135, non-renewable or conventional sources of energy. Conventional sources means those that are used regularly but they are non-renewable. So all the sources that we use like petrol, diesel, coal, all that are non-renewable gases, non-renewable sources of energy, but that is what we depend on totally. Okay, the common non-renewable source of energy are coal, petroleum and natural gas. So you can just read through those information given in red lines, nothing to study in deep. You just have to know the chemical structure or what is there in everything. Coal means it's made up of complex compounds of carbon, hydrogen and oxygen along with some free carbon and compounds of nitrogen and sulfur. So like that, you just I put a tick mark on all those red letter words. You can just read through them. That is enough. Okay. Now in petroleum, I would like to give one information. Now, when they take petroleum out from the earth, it comes out as crude oil. They take it as crude oil. Petrol doesn't come directly as petrol, but it comes out as crude oil. Okay. So, how do they get this crude oil? Usually, in some places, so much below the earth, there are some crude oil reserves. In the sense, many years back, you know how that was formed and all that. So usually that is under ocean beds. So then if they find that, there is not in every place, in some places. Now in Bombay, near the seashore, there is one place. They found that there is crude oil. So they set up a petroleum rig. Okay, it's called petroleum rig, through which they will drill a hole and have a long pipe, and then the crude oil will be pumped outside. But this crude oil that comes out will be a dark colored liquid which has lots of impurities. So it cannot be used directly. So it has to be purified or refined. Okay, then they send it to refineries. Okay, petroleum refineries. Now, what do the refineries do? There is a process called fractional distillation. Fractional distillation. They do this by which they'll get different products at different temperature. The crude oil itself, they'll heat and allow it to pass through a chamber like thing, and at different temperatures you get different outputs. Each level will be maintained at a different temperature. So things like Vaseline, tar, petrol, diesel, all this comes as a byproduct of. So in this fractional distillation happens, then there are many products that are formed at different outputs. That's why in Vaseline, if you see, it will be written petroleum jelly. Okay, it's a byproduct from crude oil. Okay, so this is just little information you need to know, that you don't get petrol, diesel directly, comes as crude oil. So that is also mentioned here, fractional distillation in big oil refineries. Then you know how LPG is made. Petrol gas liquefied under pressure forms LPG. Then you know what is natural gas. It is found deep under the earth's crust, either alone or above the petroleum reservoirs. Like crude oil, like petroleum, it is also found deep inside the earth. Okay, same way they dig wells into the earth and from there they extract natural gas. So in our country, some places they have CNG machines. You would have heard in Delhi, most of the engines are CNG, compressed natural gas. Okay, that produces less of pollution, so they depend on it. Now, the next topic is judicious use of energy. Judicious means proper use of energy, or use of energy in a just way. Okay, so many measures are given. These are the known ones only. First one, fossil fuels should be used in limited purposes. Okay, and only when there is no other alternate source of energy is available. As far as possible, we must try to depend on renewable energy sources. Second, waste of energy should be avoided. Third, cutting of trees should be avoided. More and more trees to be planted. Fourth, efforts must be taken to make use of energy in community, in groups. So one example is carpooling. Carpooling means instead of, to go to office and all, you can see one person will just go in a one car. Okay, another person will be going in his own car. Instead of that, the people in one area can gather together, go in one car, and that's called carpooling. So this is one step to use energy in community. Okay, there are these other ways also, but these four are simple and easy. You can study them. Now we come to the main part of this chapter, production of electricity from solar energy. So we'll be seeing production of electricity from solar energy, then from hydel energy, that's from water, then wind energy, then nuclear energy. Okay, so we'll go one by one. Now, the first thing you should know is, to obtain electricity from solar energy, two devices are used generally: solar cell and solar power plant. Okay, solar cell and a solar power plant. And then, what is a solar cell? The device which converts solar energy directly into electricity is called a solar cell. I'm sure you all would have seen a solar cell. It's a kind of rectangular slab-like thing on which you'll see some circles like this, and you'll be seeing some kind of lines like this. I'm sure you all have come across this. This is a solar cell. Okay, what does this do? When sunlight falls on it, it converts it into electricity. Electricity comes out of this. How is it possible? What is that? Okay, we'll see that later. Then the other way of generating solar energy from generating electricity from solar energy is using a solar power plant. A solar heating device used to generate electricity from solar energy is a solar power plant. So we are going to see about both solar cell and solar power plant in the next page. Now, what is so special about this solar cell, that it can generate, or that it can convert sunlight directly into electricity. Okay, so this material is made up of a special material called semiconductor. Okay, semiconductor. Now, what are semiconductors? They are in between conductors and insulators. So, conductors, they conduct very well. Insulators, they don't conduct at all. Okay, now in between these two, you have something called semiconductors. They conduct partially. Some substances like gallium, so in your book it's given here, solar cells are usually made from semiconductors like silicon, gallium, etc. You can just remember these two examples, semiconductors like silicon and gallium. Then come to the principle. Okay, what is the principle used in generation of electricity from solar cell? If sunlight is made to incident on a semiconductor, impurity added, if you can remember, it's fine. Otherwise, even if you remember semiconductor, that's fine. Okay, semiconductor, electricity is produced between its surfaces. Even this potential difference and all is, those terms you have not studied so far, so I am giving an alternative term. Electricity is produced between its surfaces. This forms a solar cell. So if they ask you what is the principle of energy production in a solar cell, then you have to write this. But the problem with a single solar cell is you get very less voltage from it. Means very less current will come out of one solar cell. So usually they have something called solar panels. Solar panels which will have many solar cells in it. So you would have seen this in hospitals, on top of hospitals, restaurants and all. You can see these. So each one is a solar cell, and many such solar cells are kept together in one board that is called a solar panel. So that is how it is used. So what is a solar panel? To increase the production of electricity, a large number of cells are arranged over a large area so that they could collect a large amount of solar energy to produce sufficient electricity. Such an arrangement is called solar panel. Now, the solar panel mainly has two important uses. So the next thing we're going to see is two important uses of solar panel. First thing, solar panels are used to supply electricity in artificial satellites. Now this is a very important application. So you know, the satellites, artificial satellites are sent from the earth into space. So they stay there for years and keep sending informations, photographs and all that. With that only they're able to do weather prediction and all that, right? Now these satellites, okay, they'll be looking like this, okay, the rough shape will be like this. Now this will have lots of machines, okay, computers and cameras, and which all need energy. Now where will they, you can't put so much of battery. So what these satellites are generally provided with two solar panels. Okay, they are provided with solar panels. So this is part of their structure. So this solar panel will be there. So when it is mounted in, okay, they'll mount it on surface of space, on the space, and these solar panels will so sunlight is always going to fall, not at least some hours of the day, so they're going to convert it into electrical energy, and all these machines on the satellite work with this energy only. Okay, they can't send a generator or a battery from Earth because it has to work for many years. So they usually have solar panels that converts into electrical energy. So that is the first important use. Second, for running water pumps, street lights, radio and television sets in remote, inaccessible and isolated areas. This is the main thing. Remote, inaccessible and isolated areas where conventional sources of energy are not available. Suppose in a remote place you want to put some street lights and there is no electricity in that place. So this is one way you can use a solar cell there to, solar panel to run to use those street lights. There's another use, smaller solar cells. This is about solar panels. Smaller solar cells are used in watches and calculators. I'm sure you would have seen those solar watches, solar calculators and all that. Okay. Now one more information is here. The problem with solar cell is it gets charged only during the daytime. Only when the sunlight falls on it, it can produce electrical energy. But street lights are needed in the night time. So what will they do? Usually there will be along with the street lights, if you'd have seen, so there will be a panel. Okay, this is your solar panel, and below that they will also have a box kind of a thing. Now in this box there will be a battery. So what this battery does, so during the daytime when this gets charged, it stores all the charges in this battery, and during the night time this battery will give charge to the light, and it can light the area. So there is a battery attached so that during daytime it can be stored. Now come to the next page. There are some advantages and disadvantages. Usually any two you study, that's enough. Okay, any two simple ones you remember, that's enough. Then coming to solar power plant. Now what is a solar power plant? It is generating electricity in a little bigger level. Means you can generate more amount of electricity using a solar power plant. Now basically in a solar power plant, the main part of it is a concave reflector. Concave reflector. So you all know the shape of a concave mirror, right? It will be like this. This end will be painted and this end will be shining. So this will be made to face the sunlight. So what will happen? So parallel rays coming from the sunlight, the first case of concave mirror, what will happen to all these rays? They will all meet at a single point. That is the focus of this point will be the focus of the mirror. And because all these rays are getting focused at one point, the amount of heat energy, the intensity of heat energy here will be very high. At this point, if you're able to keep something, it can get heated very fast. So what they do in solar power plant is, exactly at the focus, they will keep a tube carrying water. Okay, so water will go through this, and because this point is exactly at the focus, the water here gets really heated up that it becomes steam. It gets heated up to such an extent that it starts boiling and produces steam. So out of this tube, it's a blackened tube, a tube painted with black paint. Okay, steam comes out. Now with this steam, electricity can be generated. I'll explain that little later. So this is the principle. A solar power plant is a device in which heat energy of the sun is used to generate electricity. The sun rays, after reflection from a large concave reflector, gets concentrated at its focus. The rays have sufficient heat energy which can boil water if it is placed at the focus. This is the principle used. Before going into the next topic, I would like to explain some the general system that is used in generation of electricity. What are the main? There's one part that's common in all these energy production systems. What is that? Now basically there are two main parts in a power plant. One is called a turbine and the other one is a generator. Generator, we all know, when electricity goes off, we get electricity by running a generator. In our case, we usually pour diesel, and that energy is converted to electrical energy. Now, what does a turbine have? A turbine is basically a structure which has lot of blades attached to one point. So what happens if you can make water fall on this or steam fall on this? Because of the large amount of energy possessed by these blades will start rotating. Now, to this axis is attached a shaft. A shaft means something like a rod which can rotate. Now this rod is sent into the generator. Now basically, generator will generate electricity. Now the principle and everything you'll be seeing in 10th standard. Just understand this, that when a rotating shaft when a shaft is made to rotate, and there will be a big magnet kept here and all that. So outside you will get electricity. So all that you should know is, children, turbine. The first thing is the turbine. Turbine will have a structure like this with lot of blades. If we can rotate these blades some way, as these blades rotate, the shaft will rotate. As the shaft rotates, the generator can generate electricity. This much information you know, that is enough. So this will be a part of every power plant. Only this way, how to make this turbine rotate will be different in different systems. First, let's start wind energy. Production of electricity from wind energy. So you all have heard about windmills, basically. So they all have a structure like this. The blades will be rotating in. As the wind blows, these blades will be rotating. Now in this case, directly the shaft from the windmill is connected to the generator, because you don't need a turbine here, because already this has a shaft, and directly this rotating shaft can be sent into a generator and you will get electricity. Okay. Now let's see the principle. What you should know here mainly is, first point, the armature of the dynamo. Now armature is a part of, dynamo is the other name for generator. The armature is connected, or even if you write the dynamo or the generator is connected to a shaft. Okay, even if you're not able to remember this word, it's fine. Main thing is the generator is connected to a shaft attached with the blades of a windmill. When the blowing wind strikes the blades of the windmill, the kinetic energy of wind changes into rotational kinetic energy of the blade. Okay, the wind will make this rotate basically. Now the rotation of blades of the turbine rotates the armature. This they are calling it as turbine basically. It's a windmill. Okay, and electricity is produced. You can just write here, rotation of blades of the turbine rotates the armature of the dynamo or generator, and electricity is produced. You don't have to give all these explanations. Just write directly, electricity is produced. Again, 2 advantages and 2 disadvantages you can go through. Now coming to hydroelectricity, you know, in this water is stored in a dam which will be at a height, and then water will be made to fall from that height on a turbine. Now because it is falling from a height, the pressure will be very high, the energy possessed by it is very high, and this falling water can rotate this turbine, which will rotate the shaft that will make the generator work, and electricity is generated. See the principle here. The flowing water of river is collected in a dam at high altitude. The water has potential energy. When water from dam falls on the water turbine, the potential energy of the water stored in the dam changes into kinetic energy, and it is transferred to the blades of turbine as rotational kinetic energy. Now as the turbine rotates, it rotates the armature of the generator and electricity is generated. Again, advantages and disadvantages. If you can remember two of them, that will be fine. Okay children, I think this much is enough for today. But I want to give you some questions to for the answers for which you will be writing in your physics notebook. Already I remember you have written 7 question answers in your notebook. Now 8th question for which you will have to write the answer is, what are the 2 forms in which water and oceans possess energy? Define them. Okay, you can pause the video and note down these questions. I won't be sending it in the app. You have to see the video and note down from that. What are the 2 forms in which water and oceans possess energy? Now, the answer for this is here. This is a new thing for you. Ocean thermal energy, oceanic wave energy. Their definitions are also as those red lines you have to write. Then the next question number 9 will be, state 4 ways for judicious use of energy. Okay, note this question. Question 10. What are the 2 devices used to obtain electricity from solar energy? Define both of them. Then question number 11. Give 2 important uses of solar panel. Leave 12 and 13. That is based on nuclear energy. We'll be doing in the next class. So you're expected to complete all this question answers in your notebook. Listen to this instruction carefully. When you come for the Zoom class, you're supposed to have your notebooks, completed notebooks, and it will be checked randomly. Last week I didn't have time, but definitely this week we'll be doing it. So make sure you complete the work properly. Thank you children.